Guys, let's look at linear search. In this video, we are covering what is linear search, why we use it, Android use cases, Kotlin walkthrough, and when to use it. Linear search is also known as sequential search. It is a strategy we use to find something in a list. So we have a list of strings or numbers or products or files or anything. Um, so we want to find if a target is present. So we have a list of numbers over here, for example, and we have a target of 5. What do we do? How do we find this target in this list? We search the list one by one, checking if this particular data 5 is present in this list. This is the whole idea of linear search. Why do we use linear search for a search problem? We use it because it does not have any preconditions, unlike other search algorithms. So preconditions include sorting, indexing, or any kind of setup work that are required by other search algorithms. Now let's look at Android use cases for linear search. Think about a notes app. You type in the search bar looking for a note that you've saved last week, for example. As you type, it filters the list. You have a couple hundred notes, for example. If you have a couple of hundred notes in your notes app, as you type, it filters it. Linear search is enough for this kind of operation. It is fast and you won't even notice it is working. Okay? Now think about a shopping app like Jumia or Amazon that has thousands of products, and let's say you have 50,000 products being searched by thousands of people every minute. If it is checking products one by one, that is a problem. Okay? It will work fine when the number of products we are searching or we are testing is small, say 20 products. But if we are searching 50,000 products, it will break. The linear search algorithm will break. Now let's write a Kotlin code for a linear search. Alright, so over here we have a Kotlin code for a linear search, and the function says from linear search. This is the function itself. It takes two parameters. It has an item, that is the list that we are searching, and a target, that is a thing we are looking for. It returns an int, which is going to be the position where we found the target, or a signal that we didn't find the target. That is what this int is representing. Now we have a for loop for I in items.indices. This starts the loop. Items.indices just means every valid position in the list starting from 0. Okay? And I now will move, this iterator to move through each position of the list, and it will go through the list one by one at a time in order. Okay? Now we have items at a particular position, that's items angular bracket I equals to target. So at each position, we check the item sitting there if it is what equal to what we are looking for. We check it against the target. This is a real comparison. This is the actual comparison, the heart of the whole algorithm. Now, if this is true, we return I. That is the moment we find a match. So once we find a match, we stop immediately and hand back that position. That is return I. Okay? There's no need to check after this. Otherwise, we return -1. That is, if the loop finishes and nothing is found, no match is found, we return -1. That's our way of saying the target data or item is not in the list. So if we want to test this algorithm, we'll test it in the main function and we'll say var contacts. We'll just create a list and we'll say, let's name this Ade, Bola, Chidi, Dami, Emeka. Let's add two more, Fumi and Tunde. Okay, so this is our list of strings, list of names, and we'll now say var results is equal to linear search, that is our function. We'll pass in the contacts, that is the search space, and we'll pass in our target. Let's say we're looking for Tunde. All right. So let's print in the result. We'll say found at index results. Okay, so let's run this and check and see the results. Okay, so our result is at index 6. So let's check. This is 0, 1, 2, 3, 4, 5, 6. Right? That is I. Return I. Alright, so this is beautiful. When do we use linear search? When to use linear search? We already saw the cost play out with the Note app versus the shopping app. Linear search cost scales directly with the size of the list. So if you double the list, you double the work. There are no shortcuts because the iterator I will traverse through each element of the list. So if you double the list, you double the work. Okay? So there's no shortcut, there's no way around it. So here is the actual decision you need to make as a developer. If your data changes more often than you search it, don't bother sorting it. Just scan it with linear search. Okay? But if your data barely changes and gets searched constantly, that setup cost of sorting it once starts paying for itself fast. That setup cost of sorting it once starts paying for itself fast. And that is exactly where our next algorithms will come in. All right, in our next video.